If you've watched any of my previous videos, you might be sick of seeing these things, but I'm not. I love them. I find them very handy. Perhaps more luggable than handy, but they're luggable and they're lovable. And they've just got even handier. Now, what have we got? Systron Donna M107 DC voltage source, 2 Hewlett-Packard 3456A 6.5 digit voltmeters, 2 3455A digital voltmeters, and these ones have an annoying fan which I'd love to get rid of, and they're all connected together so I can tell this thing to produce a volt, and they all measure it. Now, this thing has been recently repaired and I haven't fully calibrated it, and this meter at the top has also been recently repaired and it needs calibration, but the three in the middle are pretty good, pretty close to each other, and you can see that 1 volt here comes out a bit low there, so if I put say 2 there, it'll come out closer to a volt. Try 3, too much, 2, 5. Anyway, very handy things, and recently these things have become even more handy. Now look, those two just changed how many digits they're displaying, and this thing's changing its voltage. These things are possessed. What witchcraft is this? No witchcraft, of course. GPIB, or HPIB, Hewlett-Packard Interface Bus, or later renamed to General Purpose Interface Bus. And all 5 of these have a connector on the back that allows the use of that interface. I thought I had maybe another 6 or 7 boat anchors that also used GPIB, but I think there's only 1 or 2, unfortunately. Well, there's a couple of others, but they're not really useful devices. So, how did this happen? There's a project on GitHub, well, I saw it on EEVBlog, so maybe that's where it was announced. It's a development of someone else's work, and it's now called AR488. 488 is GPIB's IE488, I think, or maybe it's 488 standard, so that's where the AR488 comes from. And what is it? It's a Arduino interface to HPIB. Let's have a look at the back of these things. It's a bit dark in here, sorry about that, but as you can see, there's these little modules plugged into each of those, daisy chained with ribbon cable going to this thing, and there's an Arduino there with 2 chips, a 75160 and a 75161, which are chips that meet the electrical specs of HPIB or GPIB, and so they're the recommended way to do it. And this AR488 project made a board similar to these. The lighting's pretty bad, isn't it? Sorry about that. I hope it's good enough. That project involved boards similar to that with the Arduino right on the board. And if you're only driving one device, then you don't really need these guys, 2 chips here, but when you're running a bus like this, you do. So, rather than having 5 Arduinos and 5 serial cables running back to PC, I decided to do it this way, so I made these boards, which just have 26-way IDC connectors for the ribbon cable, and a DIY homemade one for the controller. But it's the same circuit. It's just instead of going to that, it goes to this. Okay, that saves having 5 serial cables, but I've still got 5 of these bloody power cables going everywhere. So what I think I might do is make a little header thing, so these are only like 1/2 metre long, and a junction box with only 1 power cord supplying all of them. Better than this mess and needing 5 power points. Now, who doesn't like a good distraction? I've run off and made this thing, and believe it or not, there are about 25 pieces of heat shrink tubing in there, and a lot of hot melt glue, and a couple of cable ties. Yeah, this Hydra has equal length heads. Maybe I should have made it so that the bottom one was shortest and then increasingly longer, because this one might be a bit short, but what I might do is just hook it around something up here so that it sits like that. Anyway, doesn't look too bad. Certainly a lot neater at the PowerPoint end. There's only one cable. Back to these things. Let's have a look at how you talk to this. Now this is the first time I've tried to do split screen video. I'm not sure how good it's going to work, so please forgive it if it turns out a bit crappy. Anyway, we're just going to look at these three devices, the voltage source and the two HP 3456s. And how do we talk to it? Well, that little Arduino gizmo, it's from the AR488 project. I'll put a link to the thread on the EEVBlog down below. Here's the manual. Very well written. We've got 52 pages, so it's pretty good. Every one of its commands is very well described. If we go to page 16, first commands, ++ADRA. So it looks a bit like the old Hayes AT command set for the dial-up modems, if I remember correctly. I think every command in that started with ++, or maybe it was only one plus. Anyway, ++ commands go to the Arduino interface. Anything else gets sent through to the currently addressed device, and we set that address with this ++ address command. All we need is a serial connection, some sort of a teletype terminal thing. There's this thing, teraterm, pain in the ass, hate it. There's this, putty, pain in the ass, hate it. In fact, even good old Arduino's serial monitor is more user friendly, I reckon. So we'll just use this for a minute. If I go ++ ADRA 10, that's for the voltage source. So now we're addressing this guy. And if I say, it's got a very strange command set. To set these digits, you have to put in A, B, C, D, E or F, followed by the digit you want in there. So if I want, let's say 12 volts, I have to go A1, B2, so that puts a 1 and a 2 there, and then S for strobe. And now this was sitting in there before. Okay, I'll put in ++ clear, because now we've addressed this thing, address 10, so the clear command sends a reset to this, and I'll do that A1, B2, S again. So now we've got 12. I've got to set the range. That's it's currently in range 0. If I go range 1, that would give us 1.2 volts, like there. And if I go range 2, set 12 volts. Still got to tell it to output, so we have to set polarity. P1 means positive, and S for that. And now the meters are showing that value. Now I can go to the meter. I'll go to ++ ADRA 22 and say to it 3 STGI, which means go to 3 digits in the display. I'll tell the one above, well, the one above is already showing 6, I think. So we go ++ ADRA 23. We go to the space there. 6 STGI, 6 STG. It's already showing 6 digits, so 5 STG, 5 digits. Go to the one below, +22, ADRA 22. You can see this becomes a pain in the ass pretty quickly. 5 STG. No, I'm talking the one above. 5 STG. Good. Now the other meter, ++ ADRA 22, 5 STG. Good, on the same page. But yeah, that's pretty awful. So I wrote this little thing to make it easier. I'll squeeze it up a bit so it fits on the screen. So basically I just type in those same commands up here, but it remembers every command I've put in, so I can easily recall them. So if I go address 10 and then send, so now I'm talking to him, and I can send in a command like this, which sets it to 1.23456 volts. Send, and there we have it, and the meters are showing that. Or 65. Now I don't have to click it and press send like that. I can just double click like that. To read a value out of the meters, I have to select one of the meters, so that's AR488 for the bottom meter, and then go ++ read, and you can see over here we've got the value read from it in scientific notation. And the other meter, ++23, read him, we're getting the value from that guy. Let's set them both to 6 digits, so we're on the top one at the moment. Right, and then the bottom meter, +22, 6 digits. Or we can tell it to continuously send back data. We don't have to go ++ read every time. So we're on the bottom meter at the moment, and you see these lights, that's when it's doing a sample. If I say ++ auto 3 and then give it just one read command, ++ read, and now you can see it's spitting out measurements in the log over here once each time that flashes. Now if I change the number of power line cycles, if I go from 10 to 1, that's flashing much faster and the data's coming out faster. We can go even faster still if I go to 0.1, but it reduces the number of digits if I want to do it that fast. Clear now, so you're coming out pretty quick, and it can go even faster, 0.01, which knocks the digits down even more. And they're really coming out quickly now. So back to 10. And it's remembered that I wanted 6 digits, that's nice. And yeah, that's all fine and dandy, but I wanted something even better. So we'll disconnect that and throw it away, and there's this thing, which is a syntax highlighting text editor, scripting language, and a log file over here. So currently I've commented out all the stuff to do with the top 2 meters, so it's just doing the bottom 2. If I just run that, I should have connected. Good, I got to it before it needed to communicate. It should be putting out voltages here, increasing in 1, 2, 5, 10 sequence. And there's the measurements, and it's reading a measurement out of each of those in turn. And you can see the measurements here, they've got the pale blue background, which means when I want to save that to a log file, only those shaded lines will go to the log file. But while it's running, I can have all sorts of helpful information coming out in the log file. Yeah, that's been pretty useful. I've run this through all sorts of sequences and measured everything of all 4 meters, and can see how close they match. I'll stop that. This is still a work in progress. There's a lot more to add to this, but I've got a graphing application size this, and we can look at one of the measurements I made. So it went through a sequence of very low values and then up to 1000 volts, and then started again going up to 1000 volts in over a longer period. And we can look at what the other meters said, and if I put all 4 meters on, you can see they all overlay pretty well because they're much the same values. They're very close. This, you can see here, this line here is the actual voltage sent to the DC source, and because that's not calibrated, what the meters come back with is significantly different. So we'll just take that one away, take that line away. But now we're looking at just the meters, and you can see one of them, which is meter 4, the top 3455, which has been repaired and needs to be recalibrated, so we'll take that out, leaving us with just the other two lines. Yeah, we're going to look at the differences that it found between those 4 meters. So this is when it went through all the lower ranges, but if we just look at this path from here on, we're at going up to 1000 volts. This is the difference between meter 1 and the voltage source, and meter 1's probably the most accurate, so I'm measuring all the other meters against it. But because that's measuring this and this is uncalibrated, it's out by a long way, so we'll throw that line away and we can see the other 3. So these are the other 3 meters measured relative to this, and it's showing, I think it's percent. So yeah, they're very close. This is meter 3, which is one of the other 3455. Take him away, and we just got meter 1 and meter 2, and what's another mains voltage monitoring. Yeah. All work in progress, but I'm just showing you the sort of things I've been doing to talk to these gizmos and how I've been able to do some interesting things with it. Throw that away. I've got I can even, like this scripting language, I can even calculate pi. I'll run that. It's using the Leibniz series, 40,000 iterations. You can see the value compared to the real value of pi, not very close. This other method is faster, that was using logging, but you can also define screens with this scripting language, and now it's outputting the values onto a screen. This is the Leibniz. Oh no, sorry, that is nickel-anther. It's yeah, it converges much more quickly. So most of the digits are right very quickly, and it's only fussing about the last few. And nearly reached 40,000 iterations. Now we'll do it again with Leibniz, which takes a lot longer to converge. In fact, 4 million iterations, and it still won't get as close as that other series did in 40,000. That's just an interesting little aside. But now another thing I want to show you of that scripting business that I did before, I had a bit of trouble because of a bug in the Arduino business, which I'll explain in a sec. But here's that scripting language again, and I've got a meter averaging display application. Supposing one day when I get around to calibrating this, I'll be needing to measure voltages coming out of it and adjust it to get the right reading. These are my 2 best meters, and I trust this one a bit more than that one, but you know, it's still not necessarily 100% right. So until I can get them calibrated so I know which one's spot on, I want to sort of take the average of those 2. And I trust this one a bit more, so I'm going to take 50% of this plus 45% of that. And here's what we get. Connect and run this. Bring that into the middle. And it's showing the average values. It's showing the 2 meter values here, and then that weighted average along here. There's the difference between the 2 meters, and wasn't that clever? I've got a part per million difference in there, but I've got the font color set to black, so duh. Somewhere in there it's wrong, but that's the whole script to do that. Now this mess down here is very clumsy and inelegant, and I'm certainly going to simplify that, make it a bit cleaner to look at. But I reckon that's pretty good to get this happening with only that many lines of code. Now the problem I had, if we look at, I'll get that other application up where I can just send a command to the AR488 controller, this guy. If I try and reset that thing using the ++ reset command, oh, I didn't connect, that's why the send button isn't enabled. There we go. Now press send, and it goes nuts. It's in a continual reset. There's a problem with the bootloader in that particular Arduino Nano. It should be reflashed with the later bootloader. There's also an option a workaround involving a capacitor, and I've actually built it on that board. I just have to put a jumper on. I've never tested it, but yeah, if I put a jumper in there, that problem should go away. But the best answer is to put in the right bootloader. Now, I know there are other ways to do all this, but rather than using that scripting language thing, but I don't care. Basically, I want to do things my way, because I'm sure I'll hate them. I haven't looked at them. I know a little bit of them. I've had a slight glance at them, but I fully expect them to be bloatware with all sorts of intricacies, and you know, version XYZ of this thing is going to also need version ABC of something else for it to talk to. So, and I'm just not interested in trying to deal with all that crap. I want to do it my way, and I want to have full control over all of it, and have it all integrated into one program. So, and plus I want to do things that probably can't be done with those other methods, or not easily, or not simply. Like, for instance, this thing, power line monitor, or PZEM 004T, with a serial interface, and it can connect to mains and measure currents and voltages and power factors and wattages, etc. I want to be able to connect that to my scripting language and have it recording things along with these. And in another video not long, maybe it's about a year ago now, I had a 4 kilovolt power supply, which unfortunately doesn't have GPIB interface, but it's got a 0 to 10 volt analog input to control its output voltage and its current limit. And I want to make a box with D to A converters that I can send commands to that thing to control its voltage. And another box, or all in one big box, who knows, with a bunch of relays to connect these things to various points, and then use the GPIB to measure it, and have it all running through maybe even just one serial connection with a big fat Arduino at the end of it. Yeah, so that's why I'm not interested in that other stuff, because I don't think it will support the other things I want to do easily. And in any case, I love doing this sort of stuff, so that's why I haven't done it any other way. So I hope you found that interesting. Please like. It's good to see that people like these things, and I'll catch you later.